Algebra 1, Lesson 3-4, Solving Multi-Step Inequalities. Our learning target is I will be able to solve multi-step inequalities. Now I did have requests for my cat to meow again during the lesson. I cannot guarantee that that will occur. We will attempt it. Motivation. When will we need this? Well, a whole bunch of things in our lives depend on inequalities. Actually, shipping products from container cargo on ships to stores like Costco and Target, all the way to loading airplanes are all a bunch of systems of inequalities. So that's the bigger picture, but from just a student standpoint, you might need this to figure out the grade that you'll need to score to get a particular grade. So in this case, our motivation is the scores on your first 3 tests for a class were as follows: 82, 89, and 95. If you need to average at least a 92 for all 4 tests in the class to get an A, what score do you need to get on the 4th test to at least average 92? Now, the way an average works is you add up all the numbers and then you divide by the number of numbers, and that gives you your average. So we at least need to average 92. So I have 82, 89, 95, and then of course the score for the 4th test. Let's call that T. And that's 4 tests, so the number of tests we're adding up is 4, and we need that to be at least, which of course is greater than or equal to 92. So we'll figure out the technique to solve this, and then in the end we will look at the score that we needed to get the 92 average. As we saw in our last lesson, we solve these inequalities pretty much the same way we'd solve an equation. The one exception is that when we divide or multiply by a negative number, we switch the direction of an inequality. So with a multi-step inequality, we still use SADMEP. That is, we subtract and add before we would multiply and divide. So undo. And so I will undo the adding of the 13 on both sides of the inequality. 13 take away 13 goes away. I'm left with 3t greater than, well, negative 13, negative 8 gives me negative 21. And then I would divide by positive 3. Since I'm dividing by a positive number, I don't switch the direction of the inequality. 3 over 3 is 1. So I have 1t, or just t, is greater than negative 21 divided by 3, which is negative 7. So next example, we're going to be using a distributive property. We're going to solve the following inequality, and as you can see, there is a multiplier outside the parentheses, so we'll have to distribute that, combine like terms, and then isolate the variable on one side of the inequality and put the constant on the other, much like solving an equation again. So my first step is going to be to distribute that 5 to both terms inside the parentheses. So I have 5 times x, which is 5x, 5 times 3, which is 15. I have that minus 2x greater than 8. My like terms are the x's, so I have 5x take away 2x. That leaves me with 3x plus 15 greater than 8. So again, subtract before we do any multiplying or dividing, in this case, to get the variable all alone in the inequality. I have 3x, 15 take away 15 is nothing. I have the greater than inequality 8, take away negative 15, or excuse me, take away 15 is negative 7. And then I have 3 times x greater than negative 7. I undo the multiplication, of x by dividing. So I divide by 3 on both sides, and I get 3 divided by 3, which is 1. Move our solution up to the right, and I get x is greater than -7 divided by 3. And for the purposes of our algebraic work, an improper fraction is exactly what we want. In this case, we have variables on both sides, so we'll be solving an inequality with the variables on both sides. My goal, of course, is to get the variable by itself on one side of the inequality and the constant on the other. We talked about the strategy of trying to make sure we had a positive if possible, so I'm going to subtract 4n from both sides of the inequality. 8n take away 4n gives me 4n with a plus 5 greater than -7, because the 4n and the 4n cancel off. Now to get the constants on one side, I'm going to subtract 5 from both sides of the inequality. 5 take away 5 is nothing. I have 4n greater than -7 plus -5, which is -12. Undo the multiplication by 4 by dividing by 4 on both sides. 4 divided by 4 is 1. I have n is greater than -12 divided by 4, which is -3. We have two special cases. An inequality always is true in certain cases. That would be, for instance, 3 is always greater than 1, for example. That's always true. You also have the case where an inequality can have no solution. We just switch the direction of that inequality symbol. 3 is never less than 1. We can also indicate that by putting a line through the inequality. Inequality there has no solution. So let's look at how we use those ideas of always true and no solution. So our first example, we're going to solve 10 minus 8a is greater than or equal to 2 times the quantity 5 minus 4a. So writing that in inequality notation, I have 10 minus 8a greater than or equal to 2 times 5 minus 4a. First thing I'm going to do is distribute the 2 in front of the parentheses. So I have 8a greater than or equal to 2 times 5, which is 10, and then 2 times -4a, which is -8a. If I add 8a to both sides of the inequality, I end up canceling or removing the a from both sides. What I'm left with is 10 is greater than or equal to 10, which is always another example related to always true or no solution is the next example. We're going to solve -5 is greater than 7m plus 7 minus m. So first thing, combine like terms. I've got 7m and a negative m on the same side, so I'll put those two terms together. 7 of something minus 1 of something is 6 of those things, so I have 6m plus 7 on the right-hand side, all less than -5. I will subtract 7 from both sides. And so what I end up with all right, slight mistake. There should have been a 6m on the left-hand side. So Again, on the right-hand side, I need to combine like terms, so we'll do the same thing we did before. I have 6m minus 5 greater than 7m minus 1m, which is 6m plus 7. So if I subtract 6m from both sides, I end up removing the m from both sides of the inequality, and what I have is negative 5 is strictly greater than positive 7, which is never true. So this is impossible. Hence, no solution.